Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen, you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session, and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen. Welcome.
Hi, everyone. Good morning, good afternoon, or good evening, wherever you are connecting from. Thank you so much for being assisting today's webinar. We have a really interesting webinar today with 5 amazing professionals about how thermal energy storage makes variable renewables dispatchable. We have tons of things planned today, so I will be doing a couple of housekeeping rules and then we will move on to the session. My name is Cristina Galan and I will be the moderator for this webinar from ATA Insights. We also have from the backstage my colleague Rocío, who will be helping us with the chat and any technical requirements that our speakers may need. So first of all, this session will be recorded and we will be sending it to you probably in the couple of days or next week. If you have any questions, you have the Q&A box for any questions that you might have for the speakers. We will reserve a couple of minutes at the end of the presentations for these questions, and we will go as many as we can, depending on the number. And also, if you want to let us know where you're from, what your background is, we also have the chat for any conversations that you would like to start. And I see that the chat is already starting for people letting us know a little bit more about them. So that is amazing. So great. So moving on to the webinar itself, I wanted to say thank you to Women in Concentrated Solar Plus, who is collaborating with this session and is going to give us a great showcase of what's happening with thermal energy storage. We've been talking recently in the back a little bit about energy storage and how when you think about energy storage, you go directly to batteries, but there's a lot more out there and a lot of new research and development. And right now we're going to be more specific on thermal energy storage and how to apply it, its deployment, and the new technologies that are going through it. So without further ado, I am going to start with one of our first presenters of the day. Actually, this is a very interesting webinar because we're going to go to 3 different regions. We're going to start in Europe, in Spain, with Esther Rojas. She is a senior researcher at CIEMAT/PSA, which is the Center of Investigation of Energy, Environment, and Technology in Spain, and she's going to give us a little bit of an introduction of what they're doing, their research, and also a little bit more of women in concentrated solar power plus. So without further ado, good morning, Esther. Buenos días from Spain.
Buenos días, good morning, everyone. Thank you for this introduction. Let me share my screen,
Sure.
My presentation. And just to start, yeah, here we are. So as Cristina has introduced me previously, I'm going to talk a little bit about what Woman Plus Concentrating Solar Power is send a very brief overview of what the technology at the commercial level on thermal energy storage systems is in Spain, and what are the activities involved in terms of research, development, and innovation. Women for CSP is an association that was born last year in Solar Paces Conference 2023. Here you have a very nice picture of all of us, with the objective of mainly giving visibility of underrepresented genders in the concentrated solar power sector, mainly focusing on women, but all the other underrepresented genders in that technical sector. Being a technical sector, sometimes we are not visible enough. And we want to change that. And how? Well, first of all, raising awareness of such visibility, so make us visible. Organizing specific events like this one in collaboration with the great support of ATA in this case, and also providing role models and mentors for young professionals. We think that having a reference, a woman reference, sometimes makes things easier for people to be aware of the role that we can play in this technology, and also creating and enlarging our professional network within this sector. I invite you to go to our web page, and there you can find some information. I think the most important thing, or one of the most important things, is that you register in our expert database. Today we are around 100 members. And what is more important even than being a member is to fill up your profile. For example, when we were organizing this webinar, we decided to go for a thermal storage topic. We went there, look for experts on this topic, and then to invite them to participate in this webinar, make their role and their job visible. So it's very important that you fill up your profile. You can send us your news and receive ours, and be updated in all our events and all the things that we are working on, copying our calendar, and then you can follow our events. So please go there and have a look at the webpage. I don't know why, but today it didn't work very properly, well, adequately, but it seems to be a very specific problem today. Let me move to what the situation in Spain is. Yes, briefly. We have a little bit more than 2 gigawatts electric power installed of CSP in Spain, mainly between the years 2008 and 2013. This 2.3 gigawatts electric implies that the 2% of the whole Spanish power capacity installed. Half of this power plants has kind of thermal storage system. Most of them, between this thermal storage system, most of them are based on a molten solar salt storage media and with a 2-tank configuration. We have to say that the maximum contribution of this concentrating solar power installed in Spain, it's been around 9%, where that if we compare with the total Spanish power, means that we introduce 4 times what would be expected, looking at the share of the installed power. And we have several maximum daily contributions, around 5%, and monthly production about 4%, always above this 2% in the power capacity. And this is mainly because of that we have this thermal storage system. And I don't know why happened, cannot move on. Sorry, I'm trying to move on, but I can't. Seems time
the slide seems stuck.
Yeah.
Okay.
So now here we are. And here you can see a real figure production of the Red Eléctrica. I encourage you to have a look at this web page where you can find where the power generation source is and what is the demand in real time. In this case, I took this this figure of the 13th of May this year, where you can see it. Here is the demand, and I have removed all the others, but just to highlight what solar thermal, which means concentrating solar power, and PV productions we have. So as expected, the solar PV is in the middle of the day where the sun is shining, but the solar thermal is all along the day. Having a look into this detail, you can see that even at 9 and early in the morning, we have power generation, and this is thanks to this commercial thermal energy storage systems. Here we have the 640 that we are producing 600 megawatt electric. It's not much, but taking into account that we have just around 2 gigawatt installed is pretty high. So we can assure that we have reliable system in Spain since 2008. They are predictable because of these thermal storage systems, and with a very nice low cost. We are in the range of 20 up to 55 euros per kilowatt electric hour. Electric just converts to electricity. When the battery cost, this is a cost of 2020. Today is around $150 per kilowatt electric. So we are 1/3 or 1/4, depending on the technology, of the source, below the battery cost. And that is, I think, a very interesting point, and to keep in mind these figures. This is in relation to the commercial system that are quite well developed, not only in Spain. We will see more cases and more things in other countries. What I'm doing in relation to thermal storage system, I have to say, Cristina has introduced it a little bit before, that I work for the Plataforma Solar de Almería, which is very well known in the concentrating solar technology world, since it's one of the most complete installation worldwide testing for this technology. And it belongs to CIEMAT. And there is a research unit where we work on, or we have experience on simulating thermal storage system, and also, oh my God, stuck again, sorry. And also we work with the evaluation of materials, component, and equipment. So at the end, what we have experienced is in the design optimization of thermal storage system. Where I'm involved in the part of the simulation, and also on the evaluation and characterization of prototypes and experimental campaigns. I would like to just briefly go into some details about modeling. I work on developing models for thermocline and packed beds, and with the objective of have predicting numerical models. There are a lot of models relating to simulation, but none of them, as far as I know, are predicting. Always they have to be adjusted because after having erected the prototype of the system. And also working on the much more simple models. We call them analytical models, able to be integrated in a whole plant model where the computing time is important. So they are easy to handle. As mentioned before, I also work on prototype testing in the sense of evaluation of the experimental results currently, and trying to optimize the protocols developed in the Sphere 3 project for testing prototypes. And also we are quite interested in how we can transfer or extrapolate the results at the prototype level to the industrial scale. Finally, I would like to mention that I'm also involved in power to heat and to power using thermal energy storage systems, and a kind of conversion between electrical and energy and heat heat energy. Normally it is made by electrical heaters, and we are exploring the possibility of using microwaving for such a heating. There is I'm co-directing a PhD student with this topic. And that's it. Thank you very much for your attention. Yeah.
Thank you, Esther, so much for that overview of what's happening right now in Spain, and a little bit giving more visibility to women in CSP. I know we have questions at the end, but I have a question regarding women in CSP, which we left the website in case anyone wants to check it out. I've been in there this morning and it worked perfectly fine, just to let you know. Can only women register, or can men also?
No, anybody can be there, of course, and can be aware of what we are doing and invite to participate and to collaborate. So it's not only for women, but the truth is that if we want to make women visible or underrepresented genders, when organizing things, our tender will be to promote these people. But of course, anybody, whatever they are, can be a member of our community.
Perfect. Well, thank you. So everyone who is joining, I see a lot of movement in the chat, people from Italy, the USA, Chile, Morocco, Spain. Join in, Germany as well, and sign up. Well, thank you so much, Esther, for that presentation. Moving on, we are still in Spain. We're going to introduce Rocío Bayon. She is a researcher and coordinator of the thermal storage unit at CIEMAT PSA, such as Esther. She will talk about the new development of thermal energy storage in Spain, and talk a little bit more in depth about her work in PCM, which is phase change materials, and how it is impacting. Rocío, good morning. I can't see you. Can you hear me?
Yes, here I am.
Okay, yeah. There she is. Perfect.
Yeah, so I'm sharing my screen.
Okay, we're about to see it.
Okay, wait a minute. Can you see my screen?
Yes,
yes.
It's not on presentation mode, but we do see it.
Yeah, I'm going to put it as presentation. Can you see it as presentation?
Right now we can, yes.
Okay, let's check if it goes ahead. It doesn't go ahead, yeah.
It does.
Because I know sometimes, you know.
Yep, that's true.
So good afternoon, Europe. Good morning, America. Good evening, Asia, Australia. I don't know. This is all over the world, this presentation. So yeah, I'm going to talk about some the current projects and the activities we have in our thermal energy storage units. And also at the end, I will focus a little bit in the activities I'm more involved, which is the efficiencies materials. Okay, it's just 10 minutes, so I'm not going to be to talk too much about these both things. So in terms of what we are doing in the thermal energy storage unit, we mainly focus on the design, testing, and optimization of thermal storage systems, temperatures above 120, and all for integration in thermal processes and applications, not only CSP, but also can be another application that requires thermal storage. Let's say that the four main activities are, one of them is the optimization and increase the reliability of the components for the commercial thermal storage systems, they're mainly based on molten salts. And in this activity, we test the components and also try to establish the protocols for the validation of these components from the hydraulic point of view and to be implemented in the commercial systems. Another line is related to the study of the materials, the validation of materials. In this line, we try to establish also testing protocols for storage media and predict and estimate the long-term performance and their service conditions. Nowadays we are focusing on PCMs for latent storage, but we can also do it for liquid or for solid materials for sensible storage. Another line, as Esther was introducing, is the modeling and integration of storage systems. For example, simulation models for thermocline packet beds, tanks, also design of a storage system for thermal applications. And another line that is we are now developing is this focusing on power to heat concepts, which also are known as Carnot batteries. And of course, we can also do testing and evaluation of innovative storage systems, either for latent and also for sensible storage. This work is usually developed within different kinds of projects, national and international projects. And at the moment, we have the projects you see in the table, Sphera 3 and Stories, which are mainly devoted to this transnational access to installations. And also in these projects, we also do some kind of R&D activities, but mostly is for access to the installations, mainly the molten salt installation we have in Plataforma Solar de Almería with molten salts. And we have another project which is more focused on PCM studies, which is the STIS4D, which is a national project. And we also recently got the two more projects, which is the Infotherm and the Mosaico. Infotherm is really for calibrating systems for testing thermometric measurements using optical fibers. And Mosaico is another project that is more devoted to dissemination of the results obtained in the solar basis task and in relation to let's say components testing for installations of molten salts. And a part of the project, we also have contacts with different companies, especially for testing equipment and components for molten salt circuits. We also take part in different networks, like the Spanish network of thermal energy storage, and also in technology collaboration platforms, like from the International Energy Agency, like, for example, task 3 of Solar Basis, and also task 6740 from the programs Solar Heating and Cooling and Energy Storage. This is mainly activities of networking with other institutions. So focusing on my work, on the work I'm normally developing, just a short introduction about latent storage. reminding you that in this case, the storage medium changes the physical phase. And it's a process that takes place at constant temperature, and the materials used for this kind of storage are usually called phase change materials, or PCM. These materials normally undergo solid-liquid transitions. They should have a high value of enthalpy, phase change enthalpy, because the capacity strongly depends on this value. The phase change temperature, really, the important thing is that it is adequate to the application we want to do for the storage. They shouldn't have supercooling. Also, they should have low toxicity and be cheap, of course, and also stable under working conditions. And is in this last activity in which we are focusing in our unit, which is the PCM validation. What this means to ensure that the PCM is going to work as we primarily expect when it is implemented in a system, in a storage system, which implies that the properties of the material should not vary significantly during the lifetime, during the time the storage is going to work. This will depend on which kind of storage and which is the application we want to do to give to this system. So what do we need? We need really to predict this long-term performance under real working conditions. This is what we need. And how can we predict this? Well, one way is to do tests under stress conditions, and this will depend, as I said, in the specific application of the system and on the system and on the intended application. So, and why do we need to do this? Because we want to demonstrate the feasibility of the material for the commercial implementation. We have to be sure that the material we are choosing is going to work as we want. So, well, for doing this activity, we already, let's say, presented or developed a methodology that you can really check in this paper. You want to read about it more in depth in this paper that is open access. And well, I'm not going to explain it here, but let's say that the key points is, first of all, we have to determine which are the degradation factors that can affect our PCM material, and this will depend on service conditions. The test we have to perform under stress conditions, and this will be given by the degradation factors. And in the end, we need to elaborate these lifetime models that will help us to predict the behavior in the future and in the long-term performance. So what do we have for doing this in our labs are, for example, ovens that can work in an ambient air or inner atmosphere to carry out these degradation tests. So we can perform isothermal tests under stress conditions. It depends on the oven, but we can reach temperatures up to 350 or 500, I say, depending on the oven. The duration of the tests normally are between 1 hour, 6 hours. And the idea is to perform tests closer as much as possible to real working conditions, which means that samples up to 40 grams. This is what we can do. Of course, real conditions require much more mass, but for the lab, I think 40 grams is quite okay, 24, something like this. These ovens can also, in some of them, we can also perform melting freezing cycles with standby periods, and we can also do the sample monitoring, the sample temperature monitoring. So what we can do also is for this evaluation of degradation is to apply different analytical techniques, for example, thermogravimetric analysis, vis UV spectroscopy, near-infrared spectroscopy, and also at CIEMAT. In general, we have many services for chemical analysis, because if we want to study the degradation of a material, we need to analyze what is in what happens to the material. We also have computational tools for the kinetic analysis of thermogravimetric measurements. with these tools, we can estimate, let's say, the kinetic triplet for which is the activation energy, exponential factor, and the which is the reaction mechanism of this degradation process. We can also do the convolution of PTG curves with Fraser-Suzuki curves. You have here a couple of examples of the results we can get. And also we have developed an evaporation approach, because sometimes PCM degradation process of PCMs is the evaporation. So we also have developed tools for performing the kinetic analysis when the evaporation is one of these degradation processes, either for TGA measurements, either for the oven results. Okay. So just to show you, before finishing, some results that we obtained for two different kinds of fatty acids that can normally used as or considered as phase change materials. In the end, what we want to do with all the studies is to predict the mass loss over the time due to evaporation, because these acids undergo evaporation when they are in open systems. Of course, and what is interesting for us is to see what happens in temperatures close to the melting temperature, not very far, but close. Okay, so here you have the results for the lauric acid and also for the adipic acid. This one, melting temperature 43 degrees for low temperature applications. However, adipic acid 153, 154, quite interesting material for mid temperature application. So this is why it's also interesting material to study, interesting PCM. So what we see in these two graphs is that this one, if we, let's say that we have the lauric acid with in an environment in which its pressure is almost zero. So we are removing all the material that is evaporating. We can say that only about 1 kilogram per square meter will be lost after 20 years. Look at this scale, it's years, and these are mass loss. If this material is kept 20 degrees above melting temperature, but if we go to the adipic acid, which is melting at 153, in this case, even if we assume that the adipic partial pressure in the vapor phase is just a little bit above or a little bit below the constant pressure that the equilibrium pressure of the melting temperature, in this case, we would lose more than 100 kilograms per square meter only after 1 year. Look, these are 12 years, the 20 years, and these are 12 months. Even if the temperature is kept 8 degrees above melting temperature. So the thing is that we can say that in principle, lauric acid could be validated because the mass loss is very neglectable after 20 years. However, if we keep the adipic acid under open conditions in an open system that allows it to evaporate, in principle, we would have a big mass loss on the surface of the container. And so for the moment, we cannot say that it is validated. Thanks for your attention. And if you have questions, I am open for them.
Thank you, Rocío, for that overview. Very detailed. I can assume that you do not get bored. Almost never, with all the things that you're doing.
No, we are not.
No, you're definitely not. No. Well, thank you so much. It was super interesting getting to know a little bit more in depth the work that you are involved in. I see that people are starting to ask questions, which is great. I see Esther working on all the questions. If there's any that you want to respond directly or after the rest of the presentations, we will allocate a couple of minutes to the questions. After, I'm sure that there's tons for Rocío as well. And now we are going to leave Spain and we are going to move on to China. Yes, sure.
May I ask? Maybe I can answer some questions in the chat also.
Of course, yes.
Okay.
All of you can answer all the questions. Just, I think there's a little a pointer where you can just mark it, and yeah, absolutely, you can have an open discussion there. Please do, actually, because we have people from all around the world and different backgrounds, so it's interesting to maintain that discussion. So as I said, moving on to leaving Spain, but going into China. We're going to start with Associate Professor Wang. Good evening, I have to say. It's already a little bit later. Wang is Associate Professor, as I said, in the Institute of Electrical Engineering in the Chinese Academy of Science. So hello, Jan. How are you?
Hello, Christina. It's great.
Good.
Can I share my screen? No?
Yes, absolutely. While you you start sharing your screen, I'll introduce your topic, which is going to be thermal energy storage and conversion of large-scale solid thermal energy storage systems. All right, we already see your presentation in presentation mode, and you are all set.
Okay. Good morning, good afternoon, and good evening, because the time different zone. In China, there's 70. I'm great to have the chance to share my work to all of you. Today, my topic is large-scale thermal energy storage and solar energy application. I will talk my presentation from 4 parts. First, I want to introduce our institute, the IECS. In our institute, there are 7 research divisions, but the most renewable energy divisions is the Department of Renewable Energy Generation Research and Development. We focused on the solar cell, solar PV, ocean energy, and the other kind of renewable energy generation system. And the solar thermal utilization is our laboratory. This is our laboratory, and this is our CSP plant in Yanqing district. We have 1 megawatt solar town plant and 1 megawatt parabolic trough plant. We built the CSP plant from 2009, and we have worked this plant more than 50 years. During developed the CSP plant, we carried on different kind of thermal energy storage project. It's about 4 thermal energy storage for high temperature and low temperature. Because recently we focused on the seasonal thermal storage system. And I will introduce our project one by one. The first is the 10 megawatt thermal energy storage combined with thermal oil and steam. This thermal energy storage system is built in 2012. Then we we built 1 megawatt solar power town, and this is the first CSP plant in Asia. In this plant, we built 2 tank thermal oil thermal energy storage, and combined with steam thermal energy storage. This is our first thermal energy storage system. We carried many experiences with this system, and we all learn more about the performance system of the thermal energy storage. Then we also built the mental salt thermal energy storage, which is also 2 tank thermal energy storage, combined with the solar power plant, solar town plant. This system will use cement salt as heat transfer fluid and storage materials, which is built in 2016. And we want to investigate high temperature cement storage. So solid packed bed cement storage was carried out from 2030. This is our platform of the packed bed cement storage system. We used the ceramic ball as principal storage materials, and high temperature air as heat transfer fluid. The air temperature is about 800 degrees, and in order to stabilize the temperature of the air outlet during the discharge process, we also developed a new kind of latent cement storage materials, which is molten salt tuber. That is the tuber. We put the molten salt into the tuber and combined this tuber with the ceramic balls. We do more experiences and see that the air temperature can be stabilized during the discharge. Also, recent years, we developed the seasonal cement storage systems, which use the water as the cement storage materials. In Yanqing, our CSP plant, we built two water tank, which the capacity is 500 square meters. And in Hebei provinces, we use the solar concentrated technology to concentrate solar energy to heat water. And the 16 heat standard was used to concentrate solar energy. And using the 3,000 square meters storage tank, we can provide the heat for 300 square meter building heatings. And during 2 years working, the performance is very good. And then I will do the schedule of cement energy storage in China. And during this part, I just introduced some new technology of the cement energy storage. First is the sensible cement energy storage. Until 2022, the CSP plant in China has more than 600 gigawatt CSP plants. Most of the plants are used mental salt cement storage. And until 2024, there were 30 megawatt plants integrated with wide solar storage. And the capacity of mental salt cement storage will be more than 600 gigawatt until 2030. And in order to covered with core electricity plant, mental storage cement storage has demonstrated in many provinces. This is the fifth demonstrated project of mental salt cement storage coupled with core electricity plant in Jiangsu provinces. Use the two mental salt tanks to store the heat, and the heat is provided by electricity or white power. And also the solid brick the energy storage is used very popular in China. They use the migrate brick to store the heat, because the brick can use the very high temperature, maybe than 1,000 degrees, and it can. So the off-peak electricity power can be stored into the brick. And when we want to use the heat to heating building, we can discharge the heat by air or water. Because the efficiency and the temperature is very high in super CO2 CSP plant. The solid park semi-energy storage is developed. In IECS, we built a super CO2 CSP plant, and we use the silicon carbon as the semi-energy storage materials. This is our system, and we have do many experiences which verified that this semi-energy storage is very useful for these systems. About the latent semi-energy storage applications, we also do many works. First, because the PCM has very high heat resistance during the certifications. So our PhD students do some works to investigate the moisture performances. From her work, she found that the moisture can be visible and can be controlled. This is very important job for the moisture of PCM. And in order to enhance the heat transfer of the PCM unit, a new kind of technology, which called bionic technology, was used into the semi-energy storage. Many kind of bionic structure of PCM unit was development. This is bionic the leaf structures, and also this is bionic the leaf structures. This is bionic the long structures, and this is eggers. From this experiment, we find the heat exchange performances were increased and can be used as the semi-energy storage materials. Finally, I want to introduce my recent job, that is integrated solar energy in building materials. In our work, we want to use the concentrated solar energy technology into the ceramics and cement. So we do some works. This is our solar cement seating programs. We use the solar furnace to sanding the ceramics because the high densities of energy, the product is very beautiful than the common ceramics, which use the electricity or natural gas to sanding. And we also use the solar semi-energy to calculate the cement. We want to use the solar energy to instead the coal, because we use solar energy can decouple the CO2 emissions. But this work is just the start. It's just carry on, and no many results can get. We hope we can do this work successful, and we hope can cooperate with all of you. Thank you for your attention. If you have any questions, we can discuss. Thank you.
Thank you so much, Jan, for that overview and that research. Fingers crossed that the results are positive. You don't get bored either, as happens in Spain. There's a lot of things you are doing, which is very interesting. Well, thank you so much. Moving on, we'll still be in China, but we are going to move on to Teresa Gong. She is the Deputy Director of Global Business Development at Cosin Solar. Hi, Teresa, can you hear us? You're on mute.
Yes, I can.
All right. Hi.
Can you see? Can you guys? Hi, everybody. Can you see my screen?
Yes, we see it. It's not on presentation mode, but we do see it.
Okay. Let me see
Sure.
how to. Yeah.
In the meantime, just let me introduce that you will be talking about CSP-based molten salt energy storage solution.
Yes.
The development and how it's going, how it's working in China and its impact.
Oh, why? I don't know. It seems something is wrong.
I think yes. There, you have to use the last icon.
It's different from the. Sorry.
No, not at all. If you go to the bottom icon on the right, that one, you just touched
one
it.
is not
No, a little bit on the left.
No.
The one that's like a screen, a projector. There, that one.
Oh, okay, yeah. Sorry,
There
I missed it. So, hello everybody. This is Teresa from Cosin Solar, and first of all, I would like to thank you for ATA Insights and the CSP in Women to organize this event. I'm very happy to participate in this. And so today I'm gonna give you and share with you something of what's going on in China in terms of the application of CSP-based molten salt thermal energy storage technology. So my presentation is short. After the presentation, if you have any questions, just feel free to drop me an email or ask me later. So first of all, who we are and Cosin Solar. In Cosin Solar, we are basically doing R&D and the industrialization of CSP and thermal energy storage. So we have been over 10 years of experiences in development, construction, operation, and R&D of thermal energy CSP technology as well as thermal energy storage. So basically, we have 100% self-developed technology and equipment. So far, we have spent like 100 million euro on R&D. We have applied many and been awarded several hundreds of patents. So and our founding parent, Subcon Group, actually was the top one player in terms of control system and automation. So here is a simple drawing of what we do. First of all, of course, the CSP-based power plant, and also the second type, major type, is the industrialization and application of thermal energy storage, and the last part is PV tracker. So this is a project roadmap, and also through this you can basically see the evolution of application of CSP technology in China. And so as you can see, we have so far around over 100 megawatt CSP projects with thermal energy storage in operation. And of course, all of them are in western part of China. And we also have a project in Greece, which is under development right now. And since the second half of last year, we have been awarded a few more CSP projects thanks to the booming of CSP market in China, basically. So so far we have been awarded like 7 projects, in total 750 megawatt, or big CSP projects, hybrid with PV and wind, which is a kind of application of CSP and thermal energy storage, which I'm going to talk about later. So this is how the technology works. And I know there are many students from all over the world. So maybe this could help you a little bit to understand how this works. So normally CSP hybrid with wind or PV power park works like this. We build a CSP system and with molten salt storage. And on the side to that, we also install electrical heaters, which can basically take in curtailed PV at sometimes 0 tariff or even negative tariff. And then store the energy in the tanks and then discharge the energy when there's demand from the grid. So right now, this kind of CSP-based thermal energy storage has 3 major types of application. So the number one application is what I call on-grid hybrid, meaning that the CSP will hybrid with wind or PV and together form a kind of industrial park, and then dispatch a more stable power curve to the grid. So as you can see from here, this data actually is a little bit is from March, but and now we are having more actually. So as you can see in Xinjiang, in Gansu, and in Qinghai province, and also in eastern northeastern China part, we also see this kind of application altogether, almost 3 gigawatts. And the second type is what we call off-grid hybrid, like this 40 megawatts, which you can see near Lhasa. And this one is basically an off-grid hybrid power plant to supply power to a lithium plant. So lithium mining actually. So there are inside this 40 megawatt, there are CSP, battery, PV, and some energy storage, of course. And the last part, which is what I call CSP based thermal energy storage, working as the base load. For example, in Qinghai province, we are planning a 1300 megawatt CSP plant with very long hour storage and next to a PV park, very huge PV park actually. So the plan actually is to take in the curtailed PV and then dispatch the power during nighttime, the peak hour. So this is basically a simple data sheet of the application, the last application I just mentioned. So as you can see, for this one, we actually plan 1,000 megawatt in terms of storage capacity, and with 2 turbines, each is 330 megawatt. And the overall efficiency is around 75%. Actually, speaking of this 75%, we are comparing with the pumped storage. So in the market right now, the pumped storage is basically at 75%. So what we want to say is that actually you can replace or even replace some base load with this CSP-based thermal energy storage technology in China. So that's due to time constraint. This is all of my presentation, but you are always welcome to drop me an email if you have any questions. Also, I have to excuse myself because I have another call at 8. I think it's about, in 1 minute. So I have to excuse myself, but I wish you guys enjoy the webinar. And so this is my email, and you can write down my email and write me an email if you have any questions about my presentation about China. Thank you.
Thank you, Teresa, so much. And thank you so much for joining. I know that you have to skip right out to another meeting,
yes.
Another call. So thank you so much for being here today. And without further ado, due to time constraints, we are leaving China and we are going to Morocco with Khadija Elalami, our postdoc at Green Energy Park. Khadija, how are you today? Thank you for being with us.
Thank you, Christina. Hello, everyone, to this interesting webinar. I will start my presentation by sharing my screen.
Sure. In the meantime, yes, let me give a little introduction that you're going to talk about the commercial implementation of thermal energy storage in Morocco and the new possibilities with advances of packed bed thermal energy storage system using Moroccan rocks as storage materials. Very interesting. We're excited to hear more.
Yeah, thank you, Christine. So, hello, everyone. I will just present our company to those who don't know the Green Energy Park, which is a platform for research, training, and testing in renewable energy located in Ben Guerir, Morocco. So, in our platform, we have 3 main strategic visions. The first one is the applied research and innovations for the creations and transfer of know-how, as well as the development and validations of new and more adopted technology within the 3 main departments: electrical and the PV system management, solar thermal department, modeling, and the green building department. The second one is applied training, so as to create the knowledge through practice and research. The last but not least is business creations, with the purpose of creations of startup, valorizations, and commercializations of our developed prototype. I'm a part of the solar thermal department, and I'm in charge of the study and modeling of the TOS systems, thermal energy storage systems. So during my presentations, we will go through the evolutions of CSP projects in Morocco, along with the descriptions of the storage systems used in those plants. And then I will talk about the alternative storage solutions called thermocline storage systems and the research development in this field. So, as it is known, concentrated solar power plant is a technology for generating electricity using solar irradiations, and it has become a strong developed technology on a global scale. The worldwide distributions of all the installed CSP plants is illustrated by this map from solar bases, with a global installed capacity of 6.8 gigawatts electrical by 2021. So as Morocco is contributed by 530 megawatt it stands with 6th among all the country with 5 projects. And this is due to to its geographical locations and the climatic environments that encourage the large-scale development of renewable, particularly solar energy, which represents around 20% of the installed electric capacity in the mixed strategy adopted by the Moroccan Kingdom, with 17 PV projects and 5 CSP projects. And as you can see from the DNA solar map that there are a relatively high value of DNE ranging from 1,008 to 30,000 kilowatt per meter square per year, which are strongly recommended for CSP plant. And this is relatively to the Ouarzazate regions where the complex NOR 1, 2, and 3 is constructed. The first complex NOR and NOR 2 is based on parabolic throw CSP plants, and the last one is based on solar tower plants. Regarding Bni Mathar, is a hybrid solar plant combining a PV and a CSP plant. So all these concentrated solar power plants are using the mature two-tank indirect molten salt technology as a storage systems. Our colleague has already explained this process in detail, so I don't go through the details. But these systems overcome the intermittency problems of the radiations solar, with is ensure the conversions of solar energy into electricity, as this combination regulates the gap between electricity and the productions and the electricity productions and demand, and optimizes the overall performance of the CSP plant. However, this storage process or the storage systems has lead to high capital costs associated with the use of molten salts as a storage systems, so which make CSP expensive. So at this stage, the research community is reflecting on how to reduce the cost while ensuring the good performance of the CSP plants. So this can be achieved by investigating and improving the performance of the storage system through the identifications as well as the development of other alternative potential storage along with the other component like solar field, the heat transfer fluid, and the power block. So within the solar thermal department here at the Green Energy Park, we are working on this perspective in several research projects, mainly related to solar mirror cleaning, hybrid cooling for CSP and thermal power plants, CSP hybridations with biomasses, solid particles as heat transfer fluid, and more particularly thermal energy storage for CSP plants. Yes, and we are working on replacing the two-tank storage options with another passive options called the dual media thermocline storage system, which can reduce the investment cost by 35% and maintain the good performance of the CSP plants. So this system is a single tank composed of a random or ordered stack of individually solid particles like alumina, natural rocks, and slag steel. And through these void spaces of this poromedia packed bed, a heat transfer fluid like molten salts, synthetic oil, or air can be flowed to charge and discharge heat energy within or from the packet bed. In fact, the hot and the cold zone here is coexisted in the same volume without physical separations. So in these configurations, the heat exchange between the solid and the fluid inside the storage tank is based on thermal stratifications. So the main change here is how to find the most potential combinations, materials, and HTF with the high storage performance in order to fill our pilot scale thermal energy storage systems in various research and development projects. So we are focusing, we have different projects. One is related to sensible heat storage, and the other is related to latent heat and thermochemical storage as well, and solid particles as as heat transfer fluid. But in these presentations, I will focus on natural rocks as storage materials and its application in the packet bed storage systems. We are actually studying waste heat and the Moroccan rocks as storage materials. Since Morocco has a strong geological heritage, which composed of several types of natural rocks, magmatic, metamorphic, and sedimentary rock, and we can exploit for the storage applications. So in our institute, we are in our research study, we are identified and classified several candidate storage materials, and then we go through the experimental characterizations regarding the most required thermophysical property related to the storage technology. And then we go through the durability and compatibility assessment to select the most or the suitable combinations rock HTF, which has the high storage performance. And then we go through the modeling, which we can simulate the behavior of the thermal energy storage and predict its comportment regarding several materials. And then we have selected the most required, the most potential one, and we can also enhance the performance of the design of the storage systems. Next, we are proceeding to the constructions of the pilot and the test loop, and for validating the storage systems, and to finally arrive to the final phases, which is the commercializations of our systems. And this is an image for the system of the thermocline storage systems, which composed of magnetic and delcotherm as a heat transfer storage, which is implemented here at the Bengrir, at our platform GEP in Bengrir, Morocco. So to conclude, thermal energy storage is a promising technology to regulate the gap between generations and demand of renewable energy. And we are expecting to make the packet bed thermocline storage systems a mature technology soon, like molten salt storage systems. So this is my brief presentations. I will be open for further discussions, and you have my contacts. Feel free to contact me and send any other questions. Thank you, Christine.
Thank you, Khadija, so much. Very interesting presentation. We will share all these presentations with the people registered, and we're a bit over time. So I wanted to finish up this panel with a question to Esther, but I want to extend it to the rest of the speakers because I think it's interesting to know the commercially implementation of these technologies, how you as speakers see it. I'm going to start with Esther, which the question was directed to you by Alessandro, which says, what's the market demand you are registering with regard to thermal energy storage systems under development? What specific sectors you see, and if you see that the product is mature enough to scale up commercially.
Well, to say that if it's under development, it depends on which development you focus your attention to. It will have in a different kind of readiness level, let's say. So, and it's true that there are several of them that are quite close to be commercialized. Even there are some companies that are working on that has not been mentioned here. In terms of developer, I think that as far as I see two main objectives. One is concentrating solar power technologies that has not an appropriate thermal storage system. Not all the thermal storage system fit well with everything. So there are technologies on CSP which focus on reducing the cost of electricity produced in terms of increasing efficiency of solar field receivers and so on. And for that, there is not an appropriate thermal storage system, which are, let's say, commercially available. So there are some research lines on focusing on that to give answer to these, let's say, new technologies, which is not a very exactly way of saying that. And the other, I think one other point is industrial processes, which require heat for managing the heat. I would say these two things. I don't know about the other panelists, maybe they can contribute also. Yeah.
Thank you, Esther. I don't know if the rest of the panelists would like to chime in this last question before we leave. No, I'll take it as a no. But however, thank you so much. I've seen all of you answering the questions in the chat, so thank you so much. I think we need another session just for Q&As because people were very interested. So thank you all for this great overview. And thank you all the attendees for coming. And we hope to see everyone very, very soon in our next webinars and also in the Women CSP Association. So thank you, everyone. Have a great day.
Okay.
Thank you, Chris.